This is homework set 6 on linear inequalities, questions 17 through 20. Question 17, we've got another compound inequality, but this one is an OR. So what I'm looking for now are all the values of t that when I subtract 1, I get a number less than -5, or a number greater than 5. So imagine some number t, if you subtract 1, you want what values of t will give you numbers less than 5 or greater than 5. So let's just proceed as we normally would do. I'm going to add 1 over here, and then I'll have to add 1 over here, but I have to add 1 to all the parts, right? So here's what I'm going to get. T, now -1 plus 1 is gone, is less than, now -5 plus 1 is -4, or t, and that -1 plus 1 is gone, and then 5 plus 1 is 6. All right, so here's what we have now. Here's the inequality form. So the values of t that are going to make this work are either strictly less than -4 or greater than 6. Let's draw a number line. I'll label it t. Now, open circles, right? Because strict inequality. So open circles. Open circle at -4. Open circle at 6. Now, on the left, I'm looking for the t's that are to the left. So, I'm going to get these down here. And on the right, greater than 6. Now, as far as interval notations, here's what I'm going to do. I get lower limit, upper limit. Now, what have you got here? Well, this is going to negative infinity. So I'll go negative infinity is lower, to -4 is upper. Negative infinities are never included. Now, the 4 is an open circle. That's not included. Now, this is an OR. Now, in symbols, in mathematics, we use this symbol here. It's called a union. All right, this is called a union sign, and it means OR. Now, over here, we're going from 6 all the way out to infinity. Open circle at 6, that's not included. Infinity's not included. So parentheses, and there we have it. Now, here's what's happening. If I pick any number, just pick any number like this one. Okay, so just for example, what if I chose -10? Now, if I put -10 back into the original, does it work? Well, -10 minus 1, okay, so let's just try this. -10 minus 1 is -11. Now, where's -11? Well, -11, is that less than -5? Yes. Is -11 greater than 5? No. So it works over here, but not over here. But this is an OR statement. So it's an OR, at least one has to be true. So if I use -11, I get this one. So I got at least one being true. Question 18 is yet another compound inequality, and it's an OR. So we're trying to find the values of x that make either this side true or this side true. Let's see what we can do here. On the left side here, let's add 4, right? We're going to add 4, divide by 3. So let's add 4. I'm just going to do it. 3x less than or equal to, now add 4, right? I'm adding 4. So -4 plus 3 is a 1. Or, now on the right side, add 4. So we'll get 3x now, right? When you -4 plus 4, that's gone. And then over here, I'm adding 4. So 3 plus 4 is 7, greater than or equal to 7. Now, divide by 3. Alert, dividing an inequality, but by a positive number, so these inequality signs are not going to change direction. So I'm going to have this. X is less than or equal to, now 1 divided by 3 is 1/3, or divide by 3, x is greater than or equal to 7/3. Now, this is the inequality form, right? This is inequality form. Let's graph. So write x's. Now, just bring this straight down, straight down. Close circles, right? Because we got that equal sign in there. This is 1/3, and the x's, right, to the left. And over here, the x's are to the right. this is 7/3. Now from here I can get the interval notation. Where are we going here? All the way down to negative infinity. So this goes negative infinity to 1/3, right? Lower limit goes like this, lower limit to upper limit. I'm going lower to upper. Now, parentheses, always open around infinities. The 1/3 though is a closed circle because of that equal sign, so square it off, square brackets. Now this is an or, so we use the union sign for the or. And now what have we got? We've got 7/3 out to infinity, right? We're going from 7/3 all the way out to infinity. Now 7/3 is included, so square bracket, infinity is not, so parentheses. There we go. So I've got all the forms. I've got the inequality form, I've got the graph form, and I've got, I'll say it over here. This is the interval form. Question 19, a compound inequality with an or. We've got variables on both sides here, both sides here. So let's just solve these like we were solving linear equations before. Now on the left side, I've got t's on both sides here. I've got 1 here and 2 here. I have more t's on the right side than I do on the left. I'd like to get the variables on the side on which I have more t's or more, because then I don't have to work with negative numbers so often. So I'm going to get the t's on the right side. To do that, let's eliminate this one. So to do that, I'm going to subtract t, right? It's positive t, so I'm going to subtract t from here and here. Let's do that. So t minus t is gone. I'm just left with the 4. Less than or equal to, now over here, 2t minus a t is just 1t plus 2. One more step there. Why don't we just subtract the 2? Right, so just subtract the 2. So if I do that, I will get 4 minus 2 is 2, less than or equal to t. But this is that awkward situation again, right, where somebody asks you, what is t? Or where is t? And you say, well, 2 is less than t. You got to think about it. So we want the t on the left side. It's like t is, all right, so just like flip the whole thing around. If 2 is less than or equal to t, then t is greater than or equal to 2. Now on the right side, again, I've got t's on both sides here. I've got it on the left side, over here, and I've got it on the right side. Now I have more t's on the right than I do on the left, so let's get rid of these. So I've got 5 t's over here, so I'm going to subtract 5 t's. All right, so let's just do it. Now, 5 t's minus 5 t's is no t's. That just leaves us with this 3. Greater than or equal to, now here, 6 t's minus 5 t's is just a t, and then still have that plus 3. Now, let's subtract this 3. So if I subtract the 3, on the left side, 3 minus 3 is gone. That's just a 0, less than or equal to t. But there's that awkward form again. So let's change it. If 0 is greater than t, then t is less than or equal to 0. So let's graph what we have now. Well, I'll write it. I have this. T is greater than 2 or t is less than or equal to 0. This is awkward because now the larger number is to the right or to the left of the smaller number. So I'm going to switch it around and write this. T is less than or equal to 0 or t is greater than or equal to 2. So if somebody asks, what t's make this true? I can just easily say, well, t's that are less than 0 or t's that are greater than 2. Now that is the inequality form. All right, there's my inequality form. Let's graph this. All right, so these are t's this time. Now just bring these straight down. Here's a 0, closed circle because of that equal sign, a 2, closed circle. And where are the t's? Well, these t's are to the left. All right, so let's shade that side in. These t's over here are to the right, right? The arrow points to the right. So I have the inequality form, I got the graph. Now, let's get the interval form. Where are the t's here? The t's are from negative infinity up to and including 0. So lower limit, negative infinity, comma, upper limit, 0. Infinities are not included, so parentheses. But the 0 is included, so square bracket. This is an or, and or, the mathematical symbol, is that union sign. And then on the side over here, it goes, the lower limit is 2, the upper limit, it goes all the way out to infinity. The 2 is included, so square bracket. Infinity is not. That doesn't look like a good parentheses. That's better. All right, so here we go. So that takes care of questions 17 through 20, which ends our homework set number 6.